Hello, this is a demonstration of the Trapezium Rule for calculating area, and I'm going to use the MEI June 2012 question 9 as example. This regularly comes up in the MEI exam. It regularly comes up in section B, so the long questions, and it usually is fitted in. This will be the first part of a question, and the second part of a question would be to carry out an integration of a model for the same shape that we're looking at. I'll do that in a separate video because otherwise this will get too long. So this first video is about applying the trapezium rule. Okay, so let's have a look as ever at what they've asked us in the question. A farmer digs ditches for flood relief. He experiments with different cross sections and assume that the surface of the ground is horizontal. Okay, and now we've got a very nice diagram here with a series of going across coordinates, okay, left to right horizontally, and then we've got some depth here for the ditch. So let's have a look. Figure 1, this one above, shows the cross section of one ditch. Measurements are in meters, so remember what our units are for any work we do. The width of the ditch is 1.2 meters. Well, we can see that across the top. They always very kindly show us the full width here and the numbers. And it also, what's the next point says, is shows the depth every 0.2 across the ditch. So we can see that there, can't we, that we've gone from 0 to 0.2, 0.4, etc. And we've got our depths here. There's 0.5. We started at 0 over here, didn't we? Effectively, it's a 0. On the left-hand end, 0.5, 0.7. Quite regularly, they use a symmetric shape for this question. Okay, let's see what it's asking us to do then. Use the trapezium rule with 6 intervals to estimate. It's always an estimate. Trapezium rule is a method of estimation. The area of cross section. And they've got a subsidiary, quite often have their subsidiary line, hence estimate the volume of water that can be contained in a 50-meter length of this ditch. So that's just an add-on once we've done the main part of this. So let's have a look. So use the trapezium rule in 6 intervals. Well, you'll regularly find that the diagram they give us has got 6 intervals here. These are intervals on the 1, 2, 3, 4, 5, 6. Yeah. Remember the old rules, there are 6. So if we've got 6 intervals, we're going to have 7 ordinates. Yeah, so 7 points in effect, haven't we? Where we've got our depths. In this case, whatever the value is that we're going to integrate. Okay, so what is the trapezium rule? Let's do a bit of extension here. Trapezium rule, well, that is set out in the formula book on page 4. So remember, the formula book is your friend and it gives you information you can use in the heat of the exam. So let's get that. So here's the version of the trapezium rule in your MEI formula book, and let's just have a quick look at the items we've got to look for. So trapezium rule is that the area, this integral on the left, is approximately represented, estimated by this formula. So we've got 1/2 times h. So what's h? H is our strip width. Yeah. In this case, it is each of these strips, they told us, is using 6 strips we know from the diagram they've asked us to do it in 6 intervals. We know we've got 6 strips in our diagram above, and we know that each one is, our strip width is 0.2 meters. Be very careful. Common mistake is to put the full width 1.2 into there. If you need anything to check that with or to remind you, have a look at the right hand end here. It's got a little formula for the strip width. So in our case, we know that the full width is from 0 to 1.2. And how many strips are we in? Well, we had 6 strips. So that means that each strip is 0.2 meters. Yeah. You can see that from the diagram, but you can reassure yourself here. Okay. And then inside the curly bracket here, for our 6 strips, it's going to be, this is our first point, our y0. That's our y0. And this one over here, because that was our 0, that's our y1, y2, y3, y4, forgive me, y5 and y6. Okay, so these are the numbers, just to make absolutely clear. So y0 is 0, y1 is 0.5, y2 is 0.7, y3 is 0.75, y4 is 0.7, and y5 is 0.5, and we come back to y6, and again we're going to have a 0 here, aren't we? These are our 2 values, just to make that absolutely clear. Remember, these are depths, our y values that we're using for our integral. Okay, so what the formula's done for us, looking back at it, is it asked us, it does 2 things. The first section here is it looks at y0 and yn. So in our case, that's going to be y0 and y6. That was our last one. Yeah, there we go. And this second section here is 2 times y1 plus y2 plus y3. So in our case, so these ones, I would suggest we call them middle ordinates and middle depth points. So that's going to be y1 all the way through to y5. Yeah, not y6. So if we have a look at back up here, it's going to be these ordinates there. So we're looking at these depths. These are going to be our middle ones, aren't they? And we'll just leave the 2 end ones, which in this case is 0. Yeah. Okay. So can we see now how we're going to get our values and how we're going to use them? And if we remember back in the way this is constructed, what we effectively got is a series of trapeziums. So we've got an end trapezium that's got a y0, then the next one will be y1. If we looked at these, and we know what our trapezium formula is, what's the area of a trapezium? So the area of a trapezium, if we remember, area of a trapezium is A plus B over 2, so we found the average height in effect, times h, the width. And by adding these together, we can see that the first strip is going to have area y0 plus y1 over 2h, so that's the first strip, A1. And our A2, area of our second, if that's A1 in there, that will be A2 in here. So A2 would be y1 plus y2 over 2h, and A3 would be y2 plus y3 over 2 times h. And if you follow that through and you start adding them together, of course, if you now added those all together to get the total area, we would end up with our formula, wouldn't we? We can take the h over 2 outside, there's our h over 2 because that's common in all of them. And if we looked at our first group here, we'd have our y0 plus y1. Second one, we're going to add that to our y1 plus y2, etc. So you can see these numbers, the middle middle values double up. Yep, so it'll be y2 plus y3, dot, 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 dot. And if we get to the end, we come back to only having, in our case, it's going to be y6, but we're only going to have one y6, but we'd have two y5s, yeah? So that's why we end up with this h over 2. We get our end ones, which are y0 and y1, yeah, yn, and then we get all the other values doubling at the points at the values at the other ordinates are all doubling up, aren't they? Appearing twice in here, so that'll be yn minus 1. Okay, so that's how we get why we get this formula. I think it's just worth restating that, because if you can use that logic, you can always make sure that you're interpreting what you've got in front of you correctly. Okay, so let's go back and use our formula for the area. So here we have, in our case, 1 half of h. So let's have a look at our h. Well, our h value is our strip value, and we worked that out earlier. There's our h. It's each strip. It's asked us in the question to make 0.2. There we go. Okay. And now we've got our put in our as y0 and our y6 in our case, yn. Both of these were actually 0 in this case. Quite often in the examples they give you in MEI, the n2 are 0, but watch yourself so you don't get caught out. Okay, and then in the second bracket here, we're going to have 2 times. We're going to use twice, in effect. We're going to double up on the middle values, which are our blue figures here, weren't they? And luckily nice and symmetric. So we've got 0.5, 0.7 and 0.75. So let's put those in. So we'd end up with 0.5 plus 0.7 plus 0.75 plus back to 0.7 again and back to 0.5. So in the MEI cases, you probably don't need to form a table and do the calculation the long way, because they'll give you a limited number of figures, and they'll give you the values, so you don't actually have to do the calculation. Okay, so there's our area. There's our area formula, and let's just calculate it out. So on the outside now, we've got 0.1. In the first bracket, we've got 0, and in the second bracket we have, that's going to be 3.15. There we go. So our final figure is going to be, and that's 0.63, and that's in meters. It's in square meters, so that's meters squared. Can I really recommend at this point that you do a check, a quick rough check, that we've done the calculation correctly? We've got a little shape, haven't we, back there? We've got our overall shape, and if we had a quick look at it, we know that its width is about 1.2 meters. And if we went up to the top, we could get a rough, halfway depth here. Well, what's that? It's about there, isn't it? So that's about 0.5 or something. Yeah. You see what I've done? I've basically tried to find the sort of average depth. So here I've got an average depth of about 0.5 meters. So quick check. The area of that, if we made it into a rough square equivalent, as an average. So we've got 1.2 times 0.5 would give us 0.6 meters squared. So you've done a very quick check to make sure that you haven't made a calculation error. The number of times where you see the number, your final calculation, sometimes I see a student and their number bears no resemblance to what it should be roughly, just with that quick check, just looking at the volume, the area. So that's the first part of this question. That was pretty straightforward if we follow the process. Just have to recognise what we're doing. And usually then they have this final part of the question, so let's go back and read it. we've worked out here, we've estimated the area of the cross section. Now, hence, estimate the volume of water. Look at this final sentence now. Final sentence, I'm marking in green. That can be contained in 50 metres length of the ditch. So, how are we going to do this one? Well, pretty straightforward. The volume of 50 metres of the ditch. So all they're asking us to do here, and they quite often do this, is take our little cross section and extend it in 3D like that. So what's our volume going to be? Well, it's going to be the cross-sectional area times the length, isn't it? Times the length. And here we worked out our cross-sectional area estimate of 0.63, and the length is 50. So the answer we're going to get is 31.5 meters cubed. Yeah, we'll check that you've got the right dimension there. So that's pretty straightforward. How many marks do we get for that? We get 5 marks for that. As usual, here's my little summary on trapezium rule. The formula is in the formula book, page 4. Go and use it. Here's a little diagram. Important things to check at the start: get your strip width and your number of strips. They should be in the question. The data in the table or the diagram should be consistent with it, otherwise you can't solve the problem. And so check that you've got the right width, and it is the strip width. Yeah, that's our strip width. And what you don't want is the full width, is it? You need to check you've got the strip width. Let's bring one of the little strips. Then work out which are your end values, y0 and yn, and add those together. You could use a table if you want, or you could just add them together in a piece of algebra, and then identify all your middle values, y1 to yn, so that's all the values other than the two n ones, and check that, add them up, and then check that you've multiplied them by 2. Finally, do a cross check. Do a little approximate rectangle, so it's going to be the same full width, and it's going to be, roughly half the depth, isn't it? And check that your answer is consistent. It's in the same sort of order. Is it coming out with 10? They're both roughly 10, and they're both roughly 20. Not when you haven't got one that's 10 and one's 200 or something like that. And finally, just check that you've done everything correctly on the units. They're usually all in terms of the strip width and the depth in meters or centimeters, but check that they're in the same unit. So when you get your final answer, it's in meters squared or centimeters squared, and it's not some sort of weird multiple of the two. If you do that, it's a fairly straightforward process, and it should work out for you. 5 marks for that. They would then go on, and I'll show you in the next video, what they're going to do is they're then going to give you a comparative model for you to integrate. So they're doing a comparison, aren't they, of a trapezium rule estimate for the area and then your ability to integrate. So I'll do that in a second video and put that on the site as well. Best of luck.